Hello and welcome back to Math with Mrs. Becker. Today in calculus, we are going to find the area that occurs between two curves. So I think the easiest way to understand this is let's just jump right in, okay? If I look at example number 1, notice that we have two curves, in this case, two parabolas that are graphed. If I want to know the area in between these two curves from the x value, I'm going from 1 to 2. What we have to do is set up a definite integral. So I'm going from 1 to 2. Now what you have to do when you are finding the area between two curves, we have to take whatever curve is on the top minus whatever curve is on the bottom. And that's what we will be taking the antiderivative of. So in this case, on the top is 2x squared minus 4x plus 6. We have to minus the curve that is on the bottom. Negative x squared plus 2x plus 1. Okay, this is what we have to simplify. This is what we will be taking the antiderivative of. This negative would have to go to every single term. 2x squared minus 4x plus 6. Negative times a negative makes this a positive x squared. Negative times a positive makes this a negative 2x. Negative times a positive makes it a negative 1. So I still have my antiderivative from 1 to 2, because on the x-axis, that's where the area is located. 2x squared plus 1x squared is 3x squared. Negative 4x combined with a negative 2x is negative 6x. Positive 6 and a negative 1 is positive 5 dx. Now what these rules on the top are telling you is that if you have more than one term, you can separate it and do the antiderivative of each piece. Now that's exactly what we have been doing. I will take the antiderivative of 3x squared dx minus the antiderivative of 6x. I cannot see an exponent, so I'm putting that 1 there, dx, plus antiderivative of 5. There are no x's, so I'm putting x to the power of 0 dx. Now to find the antiderivative. If I add 1, the new exponent here is going to be a 3. Take that 3, divide it by the number that's already there. 3 divided by 3 is 1, so this is just x cubed. If I add 1, the new exponent is now going to be 2. Divide by 2, so 6 divided by 2 is 3. X has an exponent of 2. 0, if I add 1, now my exponent is 1. Divide the 5 by a 1, and you get a 5x plus c. So here is your antiderivative. To figure out the area between these two parabolas from 1 to 2, you have to go from 1 to 2. This is that fundamental theorem of calculus. So if I fill in a 2, because remember it's always the largest number first, then the smallest number. So if I go ahead and I fill in a 2, 2 to the power of 3 minus 3 times 2 squared plus 5 times 2. I get 6 plus c minus. Now if I change all of the 2's to a 1. Okay, so again, I can just up arrow. Anywhere where we had a variable, I'm changing it now to a 1, and I get 3 plus c. Remember, this negative does have to go into both terms, so I have 6 plus c minus 3 minus c. Plus c minus c cancels. With the fundamental theorem of calculus, the c's always cancel. 6 minus 3 is 3. It's area, so it's 3 units squared. Okay, so it is the fundamental theorem of calculus. You just have to realize that whatever curve is on the top, that goes first, minus whatever curve is on the bottom. Now here, I'm already giving us a little challenge question, okay? It says, find the area between x to the power of 3. Sorry, this is supposed to be x to the power of 2, my bad. Okay, find the area of the region between x squared, so this curve, and x squared minus 4x plus 4 from 0 to 3. Now here's why this is a trick. Let's look at this curve. Okay, now if I use a different color, let's go here. So we are looking from 0 to 3. Well, notice from 0 to 1, if I'm going 0 to 1, the purple curve is on the top. If I'm going 1 to 3, the peach curve is on the top. So the way we have to do this is we have to actually do the fundamental theorem of calculus 2 different times and then add those areas together. Okay, so the first one, let's worry about this piece right here. So that piece, I will have 0 to 1. The curve that's on the top is the purple curve, so that's x squared minus 4x plus 4, minus the curve underneath it is my x squared. Well, if I have x squared minus 4x plus 4 minus x squared and a negative x squared cancel. So from 0 to 1, we're looking at negative 4x plus 4. Again, that's dx, indicating that this is a derivative. So now I find the antiderivative of each piece, negative 4x to the power of 1 dx, plus antiderivative of 4x to the power of 0 dx. If I add 1, my new exponent will be a 2. If I divide by 2, negative 4 divided by 2 is a negative 2x squared. Here, if I add 1, my new exponent is going to be a 1. Well, 4 divided by 1 is 4x plus c. This piece, we're going from 0 to 1 because that's where this curve was above the other curve. So if I have f of 1 minus f of 0. So if I fill a 1 in here, negative 2 times 1 squared plus 4 times 1, I get 2. So 2 plus c minus, now I'm filling a 0 in there. Well, if I fill in a 0, this will cancel and this will cancel, leaving you just a c. So if I do this, I have 2 plus c minus c. So I have plus c minus c, that cancels. This has an area of 2 units squared. That is just this piece. We want to find the whole area. So now I need a whole second fundamental theorem of calculus. Yes. So if I go ahead and I look at the definite integral this time, I'm looking where the peach curve is on the top. That is from 1 to 3. The peach curve has the equation x squared. So that comes first, minus the curve that's on the bottom is x squared minus 4x plus 4. So I have to distribute that negative in because you're minusing something that has more than one term. X squared minus x squared plus 4x minus 4. Positive x squared, negative x squared cancels. So we are looking at a definite integral from 1 to 3 of 4x minus 4 dx. Now you take the antiderivative of each piece. So the antiderivative of 4x dx minus the antiderivative of 4x to the power of 0 dx. This has an exponent of 1. If I add 1, that gets me a 2. 4 divided by 2 is 2, so it's 2x squared minus. If I add 1, it's a 1. 4 divided by 1 is 4x. We are going, plus c. We are going from 1 to 3. So if I do the fundamental theorem of calculus, I have to first fill in a 3. So 2 times 3 squared minus 4 times 3. This ends up being 6 plus c minus, now if I fill in a 1, wherever there's an x, put a 1 in that location. This is negative 2 plus c. Well, if I distribute this negative 2, I would have 6 plus c. Negative times a negative would be a positive 2. Negative times a positive c is a negative c. Positive c, negative c cancels. 6 plus 2 is 8. So this is 8 units squared. Just this piece right here. They're asking you to find the total area. This portion is 2. This portion is 8. So your total area is 10 units squared. That's as hard as this will get. Okay, I started off with a basic one. Then I went right into a challenge question where you had to realize you had to do 2 separate pieces because for this region right here, this curve is on the top, but for the other region, it ended up switching. Okay, I do have quite a few more examples. Let's go ahead and do one more. And then that way you can jump to the worksheet, and if you have any other questions, just let me know. But let's definitely do one that has an E. So I do have, this is the curve x squared minus 2x, okay? Here is the curve negative e to the power of x. They want us to find the area that is in between the x values, -1 and +2. Okay, so that's where we're looking. So when I set up my antiderivative, we're going from -1 to +2. The curve that is on the top is x squared minus 2x minus the curve that is on the bottom is negative e to the x. Well, if you minus a negative, this becomes a positive. So I'm really going from -1 to 2, x squared minus 2x plus e to the x dx. So the next step, we have to find the antiderivative of this by going piece by piece. Antiderivative of x squared dx minus antiderivative of 2x dx plus antiderivative of e to the x dx. Here, if I add 1, my new exponent will be a 3. If I divide by 3, that's the same thing as 1/3 x to the power of 3. Here, this is an unwritten 1. If I add a 1, it will get you to 2. 2 divided by 2 would cancel, so I would just have x squared. The antiderivative of e to the x is just e to the x plus c. Here's the antiderivative. Now we are finding the area from -1 to 2. So fundamental theorem of calculus, you always fill in the highest number first. So 2. So let's go ahead and fill a 2 in and see what happens. So 1/3, 2 to the power of 3 minus 2 to the power of 2 plus e to the power of 2. Okay, notice you get a really big number, so I'm just going to go ahead and round it. 6.06 plus c minus. Now if I change all the 2's to a -1, so -1, got that. 2 is a -1. I'm going to insert some parentheses there too, just to make sure we know that it's going to do what I want it to do. There we go. So -1 x squared and e to the power of -1. And here again, I ended up with a crazy number, so I'm going -0.97 plus c. This negative has to go to both terms. So I have 6.06 plus c. Negative times a negative makes it plus 0.97. Negative times a positive makes it a negative. Positive c, negative c, add those two numbers together, and that's the area of that curve. 6.06 plus 0.97. We have an area that is approximately 7.03 units squared. Okay, and that's how 6.4 goes. So again, if you look, here was a very basic example. This was a challenge one where we had to actually do 2 pieces. Here's an example with E. Okay, so if you can do those 3, you're totally fine. This is a pretty straightforward question. This one, again, you'd have to do 2 because on this portion, this graph is on the top. But when you go to this side, this graph happens to be on top. So this is just the same thing as the second example. And today is a worksheet for your assignment. There's also some suggested book questions if you need more practice. I hope this made sense. Let me know if you need any additional information. Talk to you soon.